Alright, hot cookie man. Got me a cup of coffee. Video loading up. Doing its thing. Very important. This video. Just trying to figure out YouTube dollars on internet money. Playing the meme stock. Lining it up. Playing the game. And again, I don't mind playing it. I like you have the card because even though you don't play it, you have to. It's your job to. Like I said, I know the number when I put a quantum physicist next to Al or Pete about a number. Maybe not the number, but the number in their house where they absolutely crank it. Can't fucking handle it in terms of the drop off of the spin on that thing. That means I gotta play E4 or E2 or any gambit inside of there that says this is standard model under gravity. And so it makes it real easy across the board on those standards because like I said, I have to. That would be my job, playing a mass square part. You know, yeah. When you say E2 on the system, I'm playing the pawn, right? Obviously in front of the king. You gotta be a super pawn inside of there. Because I'm the bishop, the knight, the rook, playing king. Right, king? So there will be a certain set under the ground of what that looks like, who's playing what, and why, dark side. It becomes a valley under the system, understand how this game works. You know, kind of fucking base. Pick up that piece of paper, you know what I mean? That crumpled up model on the ground, the sticker. Yeah. Well, like I said, 3 blue, 3 brown, 1 blue. I don't mind. You know, this becomes a really wicked ass game of chess when you get playing it to know the game inside the standards, and that would become real comprehensive 10 to the 32nd gambit. Yeah, Google Go for masters inside of here. I'll deep fake his ass. I'll make him work. Somebody figure out the programming because I shake out a computer engineer to dump out the top limit, right? Short order on the system. So that becomes Hancock. I'm talking about, well, I like the federal regulators. You just gotta have your dick checked, right? Inside of here, I need to know that number is across the board on that standard, not some differential under the quantum mechanics of what that is. Starts with lead. Those things are in the place of G. There'd be camps and systems under the standard for the MSHA game, for the safety variables on what that does. Sometimes the operator has to do things like the reason we have mechanics is not because those serviceability ratings are perfect, nor GPT-3 can handle it, his metal ass anyway. Sensor break loose unless you have a little robot to figure out the programming on that. And then why do you need a robot? We have plenty of robots. It's about training on the system. You can do other things. These ones can swim. By asking them, I push them hard enough to usually this becomes those things. Like I said, I don't mean to do it. It's also a big system across the ground. You gotta have that physics. Definitely need to have that physics, and this comes with another video, and I'm probably going to post this one deep dilated into the system that correlate into the value under the standard. Oh, she wasn't done. Oh, she is done, but that's alright. Upload another one. Get this back one here. What it looks like, guys. Doing your thing. I sometimes hit a full review, and I'll hit these videos twice. Sometimes I don't. Post. Fuck it. We'll deal with its title later. Sitting out thinking that we're dealing with a hot cookie right now. You're running it. Yeah, under the keel. Well, you would. You'd pick up on little differentials that actually would lend somebody back across the board and geodesically deal with all this, net negative, net positive, being a system. Well, there's one about drug trial. My Huckabee cinnamon pill is pretty comprehensive to just, well, you're not going to change the nature of a fucking cobra. You're still going to use sticks and stuff like that, and the venomous reptile handling handbook. There's what happens in this. That can be a variable. Most of the time in good incidents you'll see a great standard, you know, getting those inches back, weaponizing venom in the form of a hospital and anti-venom and that whole CDC area over there of making money and dealing with it. Well, somebody's going to go, well, people get hammered by bush smashers out in Africa, dude. It's dark and there's a lot of fucking sketchy shit over there. Well, that's my money. That would be that middle hit comparatively to, you know, who is it Fauci talking about, you know, what to do with Wutan CDC clinic facility if it come up at the water cooler today. And honestly, that's going to be me and the stone mill in one half, one step off. King, Bishop, Rook, what are you doing? Yeah, it's a good way to play it because then you can play different games. But if you couldn't handle that version of it first, real simple, 0, 1, 2, 3, how many ever pieces you actually got building your chessboard, figuring out hydrogen for the first time and putting it in fluorohydramonium. So what do we got? No deal. I'm making money, they just don't understand it. It's a lot. It's deep comprehensive on what it is you ask for in short order of me figuring it out across the board. Took me a while. Got it wrong a bunch. Well, nuts. You want to get deep web about it, we're going to have to tank this stuff like this is crank and rock.
If you wake up worrying...
Oh, that was funsies. No.
Am I going to get evicted?
Carl Sagan.
Am I going to have enough money for my utility bills?
Think about it.
This is a 3. It's sloppily written and rendered at an extremely low resolution of 28 by 28 pixels, but your brain has no trouble recognizing it as a 3.
Great.
And I want you to take a moment to appreciate how crazy it is that brains can do this so effortlessly. I mean, this, and this are also recognizable as 3s, even though the specific values of each pixel is very different from one image to the next.
Muon that's
the
running around
particular
in the skull
light-sensitive cells in your eye that are firing when you see this 3 are very different from the ones firing when you see this 3.
On K-class,
but something in that crazy smart visual cortex of yours resolves these as representing the same idea, while at the same time recognizing other images as their own distinct ideas. But if I told you, hey, sit down and write for me a program that takes in a grid of 28 by 28 pixels like this and outputs a single number between 0 and 10, telling you what it thinks the digit is, well, the task goes from comically trivial to dauntingly difficult. Unless you've been living under a rock, I think I hardly need to motivate the relevance and importance of machine learning and neural networks to the present and to the future. But what I want to do here is show you what a neural network actually is, assuming no background, and to help visualize what it's doing. Not as a buzzword, but as a piece of math. My hope is just that you come away feeling like the structure itself is motivated, and to feel like you know what it means when you read or you hear about a neural network,
and then I'm going to check your nuts real good. Now that you know how to play me.
This video is just going to be devoted to the structure component of that.
The
following one is going to tackle learning.
Go blink.
What we're going to do is put together a neural network that can learn to recognize handwritten digits.
The joke, Sarge. The joke.
This is a somewhat classic example for introducing the topic. And I'm happy to stick with the status quo here, because at the end of the 2 videos, I want to point you to a couple good resources where you can learn more, and where you can download the code that does this and play with it on your own computer.
You wouldn't be able to set this card up.
There are many variants of neural networks, and in recent years there's been sort of a boom in research towards these variants. But in these 2 introductory videos, you and I are just going to look at the simplest plain vanilla form with no added frills. This is kind of a necessary prerequisite for understanding any of the more powerful modern variants, and trust me, it still has plenty of complexity for us to wrap our minds around. But even in this simplest form, it can learn to recognize handwritten digits, which is a pretty cool thing for a computer to be able to do. And at the same time, you'll see how it does fall short of a couple hopes that we might have for it. As the name suggests, neural networks are inspired by the brain. But let's break that down. What are the neurons, and in what sense are they linked together? Right now, when I say neuron, all I want you to think about is a thing that holds a number, specifically a number between 0 and 1. It's really not more than that. For example, the network starts with a bunch of neurons corresponding to each of the 28 times 28 pixels of the input image, which is 784 neurons in total. Each one of these holds a number that represents the grayscale value of the corresponding pixel, ranging from 0 for black pixels up to 1 for white pixels. This number inside the neuron is called its activation. And the image you might have in mind here is that each neuron is lit up when its activation is a high number. So all of these 784 neurons make up the first layer of our network. Now jumping over to the last layer, this has 10 neurons, each representing one of the digits. The activation in these neurons, again, some number that's between 0 and 1, represents how much the system thinks that a given image corresponds with a given digit. There's also a couple layers in between, called the hidden layers, which, for the time being, should just be a giant question mark for how on earth this process of recognizing digits is going to be handled.
Then I'm going some backwards combination where it's that, and then totally wild-ass random.
And admittedly, that's kind of an arbitrary choice. To be honest, I chose 2 layers based on how I want to motivate the structure in just a moment.
This way,
and 16, well, that was just a nice number to fit on the screen. In practice, there is a lot of room for experiment with a specific structure
here. If it does certain things by
the way the network operates,
of how that vector works, like I said, then you have
determine
cicada
the
cipher,
activations
hidden
of the next layer. And of course, the heart of the network, as an information processing mechanism, comes down to exactly how those activations from one layer bring about activations in the next layer.
You know, they're closing
it's
it
meant
off
to be
under the gap,
loosely
because that gives
analogous
it
to how in
limits.
biological
Figure
networks
out
of neurons, some
Alpha
groups of
Centauri is
neurons
doing
firing
today,
cause certain others to fire.
Or
now, the network I'm showing here has already been trained to recognize digits, and let me show you what I mean by that. It means if you feed in an image, lighting up all 784 neurons of the input layer according to the brightness of each pixel in the image, that pattern of activations causes some very specific pattern in the next layer, which causes some pattern in the one after it, which finally gives some pattern in the output layer. And the brightest neuron of that output layer is the network's choice, so to speak, for what digit this image represents. And before jumping into the math for how one layer influences the next, or how training works, let's just talk about why it's even reasonable to expect a layered structure like this to behave intelligently. What are we expecting here? What is the best hope for what those middle layers might be doing? Well, when you or I recognize digits, we piece together various components. A 9 has a loop up top and a line on the right. An 8 also has a loop up top, but it's paired with another loop down low. A 4 basically breaks down into 3 specific lines and things like that. Now, in a perfect world, we might hope that each neuron in the second to last layer corresponds with one of these subcomponents. That anytime you feed in an image with, say, a loop up top, like a 9 or an 8, there's some specific neuron whose activation is going to be close to 1. And I don't mean this specific loop of pixels. The hope would be that any generally loopy pattern towards the top sets off this neuron. That way, going from the third layer to the last one just requires learning which combination of subcomponents
so now that you know
corresponds
that stuff,
to
like
which
I said,
digits.
1, 2, 3, 4,
of course,
5,
that just
6,
kicks the
7.
problem down the road, because how would you recognize these
1, 6,
subcomponents
good.
or even learn what the right subcomponents should be? And I still haven't even talked about how one layer influences the next. But
ZYXWVTSRQPONMLJKIHGDEFCBX.
One reasonable way to do this would be to first recognize the various little edges that make it up. Similarly, a long line, like the kind you might see in the digits 1 or 4 or 7, well, that's really just a long edge. Or maybe you think of it as a certain pattern of several smaller edges.
Get away with it.
So maybe our hope is that each neuron in the second layer of the network corresponds with the various relevant little edges. Maybe when an image like this one comes in, it lights up all of the neurons associated with around 8 to 10 specific little edges, which in turn lights up the neurons associated with the upper loop and a long vertical line, and those light up the neuron associated with the 9. Whether or not this is what our final network actually does is another question. One that I'll come back to once we see how to train the network. But this is a hope that we might have,
be able to line
a sort
it
of
up.
goal with the layered structure like
I was in this for a while.
Moreover, you can